everyone, thank you so much for clicking onto the video. Here are today's learning objectives. So the first is to use 2,4-dinitrophenylhydrazine to detect the presence of a carbonyl group in an organic compound, and then to use it to identify a carbonyl compound from the melting point of the derivative. And then we're going to be looking at the use of Tollens reagent to detect the presence of an aldehyde group and distinguish between aldehydes and ketones, explained in terms of the oxidation of aldehydes to carboxylic acids with reduction of silver ions to silver. Now we're going to look at Tollens reagent. So Tollens reagent contains the ion AgNH3 and this is a plus ion, and it's made from silver 1 nitrate solution, and in order for us to prepare it, we add a drop of sodium hydroxide solution to give a precipitate of silver 1 oxide, and then add just enough dilute ammonia solution to redissolve the precipitate. And this reagent is used to distinguish between aldehydes and ketones. And the way we test it is by adding the test sample to some freshly prepared Tollens reagent, and we have to gently warm the mixture. So the reason this test works is because aldehydes can be oxidized further and ketones cannot. So we know that aldehydes can be further oxidized to carboxylic acids, whereas in ketones, we don't have a CH bond because, for example, if we look at propanone, we have CH3, C double bond O, and CH3. And so the only bonds we have that we're trying to break are the C single bonds and this C double bond O. And these take a lot more energy to break compared to the CH bonds in an aldehyde, for example. So when we look at propanol, so we have CH3, CH2, and then C double bond OH. So this CH bond here is much easier to break compared to the the carbon-carbon single bonds and the carbon double bonded with the O. And so this is why the test works. And this is also because Tollens reagent is actually an oxidizing agent. It's a mild oxidizing agent. So it oxidizes the aldehyde slightly and it won't oxidize the ketone. And so for propanol, what it does is the propanol, we have CH3, CH2, and then C double bond OH. And so what this does is we add some of this Tollens reagent, so some oxidizing agent. So I'm going to represent it by a square bracket O. And then we're going to form propanoic acid. So CH3, CH2, and then C double bond O, OH. And so the equation is already balanced, and so this is our oxidation reaction, the oxidation equation for propanol. And what happens to the silver is that it gets reduced. So we have Ag plus ions in this original ion here. We have Ag pluses. And so as the propanol is being oxidized, this silver compound, Ag plus, is being reduced. And so we form silver, the solid. And so this is why a silver mirror appears. So this is our silver mirror. And it forms around the test tube. But when we look at ketones, ketones can't be oxidized any further. And so the Ag plus ions aren't reduced. And so we don't get a silver mirror for a ketone. And so key things are that aldehydes can be oxidized further. And so what that means is that because this Tollens reagent is an oxidizing agent, the aldehyde is oxidized. And so what this means is that the Ag plus ions in the reagent are reduced. And so we have that a silver mirror forms. Whereas when we look at ketones, they can't be oxidized any further. And so what we get is no reduction of these Ag plus ions in the reagent. And so we don't get any silver mirror. And so this is how we distinguish between aldehydes and ketones, because when we add Tollens reagent and warm the mixture, aldehydes will form a silver mirror around the test tube, whereas ketones won't. Now we're going to look at the reactions with 2,4-dinitrophenylhydrazine. So 2,4-DNP reacts with both aldehydes and ketones, and the product is actually an orange precipitate. And so this means that we can use this 2,4-DNP to identify if a compound contains a carbonyl group, so contains the C double bond O group. If it contains this C double bond O, this is a carbonyl group. So this is a carbonyl group. And after that, we can then use Tollens reagent to differentiate between an aldehyde and a ketone, because aldehydes can be oxidized further, whilst ketones can't. And so aldehydes will produce the silver mirror by reducing Ag plus ions into silver, compared to ketones, which won't have any effect. And the melting point of the crystal formed can also be used to help identify which carbonyl was used. And so we take the melting point of orange crystals produced and compare it with known values in a database. So I'm going to have a quick look at the reaction that happens when we add this 2,4-DNP to, in this case, an aldehyde. So we're adding it to ethanol. And what happens first is we get electrophilic addition, because this 2,4-DNP is acting as an electrophile, because the nitrogen has 2 electrons which it can donate to the partially positive carbon, which we have here. And so electrophilic addition happens, so we get this new molecule. And then what happens is that we eliminate water to form an alkene. So remember back to when we were doing alcohols, dehydrating alcohols to form alkenes. So that's basically what's happened. And this product is an orange precipitate. You won't need to know this. This is just so you get a clear idea of what happens.